Hi, I'm going to introduce the dynamic range. Since this is a complex topic, I will try to explain it in simple words and images. According to the book, Digital Cinematography Fundamentals, Tools, Techniques, and Workflows, the dynamic range of a scene is the ratio of the maximum and minimum light levels in the scene. The dynamic range of a camera is the ratio of number of stops of latitude a sensor is capable of recording. Another book says, dynamic range is the steps from dark to light that the camera can capture without loss of detail. For example, a song that I like has a range from low to high, like the brightness range of the scene, and the range that my voice can sing from low to high is like the dynamic range of a camera. Suppose the grayscale chart of the scene is 16 stops, and the camera may only record 8 stops. So, anything darker than this is black in the camera, and anything whiter than this is white in the camera. The dynamic range of a camera depends on its sensor and the ISO used. It determines the degree to which the camera can retain both dark and light detail when shooting high-contrast scenes. The greater the dynamic range, the better the camera can adapt to different lighting conditions, capture rich layers, and color spaces. How can we test dynamic range? Let's move on. Part 2. This book also gave us an answer. To test a camera's dynamic range, David Mullen ASC suggests shooting in the widest format and also in Recce. 709 for comparison. Place a black card, an 18% gray card, and a white card together. Gradually underexpose in one-stop increments until the black card and gray card look the same. This shows the stops below 18% gray. Then overexpose until the white card and gray card look the same. This shows the stops above 18% gray. This method determines the total dynamic range the camera can capture. Also, there is a fast way to check the dynamic range in the field. First, setup. Frame includes a person, interior wall, curtain, and exterior with bright sky and detailed objects. Second, measure bright areas. Use a spot meter or zoom to read the bright sky or wall outside the window. Third, measure dark areas. Take a meter reading of the person's face inside with no lights. Fourth, compare stops. Note the difference in stops between the face and the brightest area. Fifth, adjust exposure. Set exposure so the bright area is detailed but not overexposed. If the face is too dark, dynamic range exceeds the camera's capability. Sixth, add light. Add one stop of light to the face by using a reflector or shining a light on the person and measure. Repeat until the face and exterior are both within acceptable exposure. Seventh, determine dynamic range. The total number of stops added to balance the exposure shows the dynamic range. Part 3. Cyned, which is a third-party photographic equipment evaluation website. Testing method evaluates the dynamic range of the Sony a7S III by analyzing the SNR. This diagram was made in a completely dark room using a backlight transmometer named this, which provides 21 levels of brightness corresponding to the dynamic range of the camera, and by taking this table with the camera, we can see this distribution in the vector diagram using the software. Generate this graph according to IMATest, the dynamic distribution under each SNR. SNR is the ratio of dynamic range to noise. SNR 0. 5 is very good, and the A7S III has a dynamic range of 12. When ISO is 16,000, the dynamic range is about 11. Also, they did a dynamic ranking for that, and the Sony a7S III came in here. Part 4. When we take pictures of the sky outside, we often find that the sky turns white, or the sky color is normal, and the building is very black, which is also because of the dynamic range. But what we see with our eyes is not what the camera sees. As David Stump says, the dynamic range visible to our human eyes usually has 30 steps. Dynamic range of such magnitude cannot be recorded by any current photographic device except by integrating numerous successive bracketed exposures. We can use the camera to take HDR pictures, but it's only for JPG. Then we can get photos of different exposures, import them into Photoshop, combining them into one picture. Since the dynamic range of the camera is a certain range, if we want to shoot a specific range, we can also use ND filter, add light in the darkest place, use reflector and other light. This is my understanding of dynamic range with quoting a lot of sources, and hope you understand this more clearly by this video. See you.